People that are mad at problems on 1 to 13, so what do you bring me with a number?
2.
2. So 2, they want us to look at table 4, 5, and they want us to plot ourselves a little graph. So, are the times the x's or y's?
The X's.
They are the x's. So the distances are the y's. So this is the one where I was saying yesterday you were going to need a piece of graph paper to successfully do 2. So if you didn't use graph paper on 2, you weren't going to be able to do D at all. Because to do D, we're going to need to have graphed this on graph paper. So if that didn't happen yet, grab a piece of graph paper, graph those points. I would count on the x-axis by ones. The y-axis, probably not count by ones, because you have to get all the way up to 50. So count by 2s or 3s or 4s or 5s or something. I wouldn't count by something larger than 5s. I might count by, well, you're only using one piece of graph paper, so maybe count by 2s, because you're never going to use that graph paper again. You might as well get your money's worth out of the graph paper. I wouldn't count by 1s to 50, but count by 2s to 50. You get a nice big graph out of that maybe. If you do the graph, what graph is A going to look like?
Increasing.
Yeah,
Square variation.
the direct square variation. Yeah, 2A, if you do the graph right, is going to look like a direct square variation graph. Does anybody need help in doing A, or is that verbal advice enough for A?
That's it.
Okay. For B, they ask you the name of that curve, and that's not super important. I think they dropped this word in earlier this year. It's like a U-shape in essence. It's only half of a U, but it's still a U-shape. Does anybody math trivia remember the official technical name of a U-shaped graph? It is a parabola. If you remember that, great. If you don't remember that, that's not really like the be-all and end-all of physics to know the name parabola. C, grab my chalk and we'll talk our way through C and D, but I don't have graph paper. So we're looking at a thing like this. It went as high as 50. This was a distance axis. This was a time axis. So on C, they ask you to find a distance when we've done 2.2 seconds. Can anybody describe to me how I could use this graph to figure out a distance for 2.2 seconds?
Could you just go over kind of where 2.2
We go over and kind of guesstimate where 2.2 is.
and then go up,
You go straight up,
and then
find a
left,
point on the graph that draws our attention,
and then go over to the distance.
and then track straight across and kind of guesstimate what distance it is. Is that going to be super precise? No. But if you used your graph paper to have a graph this big, compared to someone else who used their graph paper to make a graph that big, whose answer is going to be better?
The big
The
one.
big one for sure. So that's why I was saying maybe count by 2s to 50. Just because if you counted by 5s to 50, that might be so crushed you can't even like do much with it. When you go to do D, we're trying to find the slope of a curve, and I told you yesterday this is a one-time deal for your physics career unless you go on to do something for a college setting somewhere. We're trying to do the slope of a curve. So we would go to 3, we'd go and find the point that lines up with 3, and then what was the wordsy answer about that does make the review sheet in the test?
With the tangent.
Slope of the tangent line. A tangent line means I'm only going to touch that point. And when I'm in here, that curve in close to that point is pretty close to straight. Like the overall graph is not straight. But right here in this area, that's pretty close to a straight line. So what we're trying to do is basically mimic that straight line on our graph paper. And then somewhere, this line is eventually going to clip
corner.
a corner, or be close enough that we'll act like it did. And somewhere over here, we should be able also, anywhere, doesn't matter where, but we need to find how many corner clips.
2.
2. Any 2 corner clips anywhere on our graph paper, and then find the slope of those. Is everybody's answer on D gonna agree? No, it's guesswork. They're guesstimating in mine that it's like 12-ish. They guesstimated C was like close to 10. They did like 9 point something. They guesstimated D to be like 12. But if somebody got C to be 10 point something or 11 point something, I mean, who knows? That might be okay. If you said 80, well, that's nuts, because the graph only went to 50, so it's got to be something close to 10-ish. Likewise for the slope. If somebody thinks they have a slope of 12, and somebody else has a slope of 15, and someone else has a slope of 10, that's okay. But if you think the slope is negative 40, well, that's off the wall. Does that make sense for that one? As advertised, the questions get better as you go. Like the last few are better than that first few. 2 was pretty bad. Something else? Yeah?
So 6, 7, 8 didn't make sense to me because I didn't understand 6 to begin with.
Okay. So 6, they want us to make a table of speeds at the end of each second. 5 seconds worth of free fall from rest. What does that mean in more common terms? Free fall from rest. What did they do?
They dropped.
They dropped something. So they're at the top of the Leaning Tower of Pisa or the Empire State Building or wherever they go. They're at the top of a building and they just drop stuff and just let it drop. So they want us to make a table times from 0 to 5, I think, right? And they want us to do, I'll say, final velocities. Can somebody give me a final velocity equation from olden days that has time in it? Because that's the only thing they did give us is time to work with.
VO.
Good.
VO plus AP.
Okay, that'll work. What is the VO when you drop something?
0.
0. What's the A of anything in the air?
9.8.
So we're just going to need to take 9.8 times these and table that up. If you do 6A right, it should be, did anybody do 6A, they think, right? What shape did you have if you did it?
So on.
It's a special line. Anybody sit there? What's the only special line I could even be talking about?
Direct variation.
Direct variation. Should be a straight line coming out of the origin on that one. Then we're into a vocab answer, because they would expect you then to make a graph with velocity on it. They ask you on a velocity graph what the area is, and that's something that we could have either memorized or we could reason it out either way. Anybody on a velocity graph doing the area? What's it about? It is the distance. Is that okay on 6? Did you have a cluster of questions or was it just 6?
Well, I needed 6 to understand 7 and 8.
Okay, 7 is a similar thing, but 7, they don't care about velocity. They want to build this same kind of table again, but do distance. So somebody other than Alyssa, give me a distance equation that could help us fill in this table.
S equals VT.
We could, but we don't know the V.
Half
Half A squared. Because we know the A is 9.8 and the T's are what's coming from our table. So when we go to do 7, we can make a table with that. They'll want us to make a graph out of our table. And then I fibbed to you. On the C, they're asking you for slopes of the curve again. So how are we going to do slope of a curve again? Tangent line graph paper again. I'm sorry, it was 2 that we did that. I didn't realize there was a second one of those. 7C is going to be another like tangent line kind of graph. So you have to do that twice in your physics career.
They're not eight,
Does 8 do it too?
Yeah. See.
No, it doesn't, because 8's a straight line. On 8, they want you to make a table with the same distances, but the times get, what do they say on 8 about time? Times squared, which makes the 2 4, and 3 is, and 4, and 5. And when you do the squaring, it actually does not produce a curve anymore, it'll produce a straight line. 8's graph should be like another direct variation kind of graph. So you're doing the slope of a straight thing. Yeah,
Why'd you say curve then?
it shouldn't. Did you square the numbers in your table?
No, I'm just saying for seeing the question, it says, it asks you about curves, that's why I got confused.
Well, but it's not a curve.
Okay.
I guess they're considering a line to be a type of curve, but it isn't a curvy curve in the true sense of being curve. It should be a straight line once you squared that stuff. I mean, that's a mean cluster there. 6, 7, 8 mean cluster. 9 to 13 gets better again. 9 to 13 is like doing the back of the quiz from yesterday. More problem-y problems, a little bit of advice to work through the world. Yeah. One. So, one, they're giving you a table. That table 4.4 is where we can look. And they want you to take that table and make a graph. So, as always, the times are on the x-axis. The speeds will go on the y-axis. Were you able to graph the graph? To understand how to graph the graph.
Yeah, but like, I don't know, I've been a little lost.
So we've got the times are going 1, 2, 3, 4, 5, 6, 7, 8. And then when we look at the y's, I only need to count to 20, and they're counting by 4s, so I might as well count by 4s also. So the first data point they give us is 0, 0. So you stick that,
The origin.
the origin. And then we're gonna go 1/4. So like there. Keep going, we'll talk in a minute once you get your graph made without me.
Gotcha.
Anybody want to talk about anything else while we're waiting for the graph from 1 to appear? 8. So I sort of already did 8 when we were talking over there. So let's see if we have a new question before I redo the same question again, because we could do an instant replay off of the YouTube channel if you had to. Anybody have something we didn't do yet before we start the double dip back into the same questions?
You could just do the slopes on that one, right?
3, we want to do slopes, yes, on like the different, 4.9. Yeah, we're doing like the slopes of each piece from the picture they drew there on the bottom left. So
Do the triangles up till 4.
you are not going to do anything with areas until 4, yeah. So 3 is a question about you finding the slope of each piece. 4 is a question about finding the area of each piece, which is a mix of triangles and rectangles.
For 9 to 11, when it's asking about motion, does that just mean like increase, decrease, 0?
you need another word. So like you could say increasing speed or increasing, something. Yeah. It's like doing the backs, like doing the back of the quiz. Instead of the back of the quiz yesterday, I said like a situation and you made a picture. They're making those same pictures. They want to know what's the name of that situation. And there's synonym ways to say that. Like somebody could say zero velocity. What's a synonym word for zero velocity? Rest. So they're both right. Somebody could say increasing velocity. Someone else could call that speeding up. Someone else could call that speeding up. Velocity increasing is moving with.
Fastness.
Not necessarily. It's not necessarily fast though, just because you're speeding up. Acceleration is correct. So you could say it's accelerating, or you could say it's speeding up, or you could say the speed is increasing. Sometimes there's interchangeable phrases for those situations. What do you think of your graph?
So it goes straight up and then it like goes flat.
Yeah, that's correct. And then they're going to start to ask you like a series of questions about it.
Okay, I think I just
So-
needed help with the graph.
Yeah, it's a speed graph, because the table was a speed table. So if we're gonna do B, how on a speed graph can you answer distance questions? How do speed graphs give you distance answers?
Oh,
The area. So what you're gonna have to do is do some areas. So that shape to do B. C is another distance question, so that's another area. D is a distance question, that's another area. E is a slope question, F is a slope question.
Okay,
Are you okay with the maths on those?
I think so.
Okay, you just didn't like the graph to get it started. More stuff here?
Number 1D.
1D, you're gonna have to work off of this graph and find the total area of everything, which is gonna be a triangle plus a rectangle. Do you remember the geometry of how to do areas of rectangles or triangles? Okay, so anybody remind us, maths, process, area of a rectangle, how do we do that?
Just multiply between the sides.
We do how wide it is times how tall it is. How's a triangle different?
You cut it in half.
Cut it in half. We go how wide times how high, but it gets cut in half. Because if you look at this space, you can kind of see this triangle is half of the space. Triangles we always cut in half. Other stuff to try to nudge you along in a good direction. Surprised no one asked about 5. 5 is like the bendy one I did yesterday. I don't know if people like that for the example. People are not in it yet. People usually ask about 5. 5 is like the curvy thing from yesterday is what 5 is about. Anything else I can do for people? Okay, so we'll go instant replay of 8 then, I suppose. So 8's launched off of 7. So instant replay of 7 to build up momentum into 8. 7, they wanted us to build a table of distances. So to do that, somebody give me an old S equation that can get me distances that has t in it. Disagree with that in this setting because we don't know v. Half at squared. So we're going to have to build a table by plugging these numbers in for the t where it gets squared. And what do we know about the free fall? A, the acceleration, 9.8. Okay.
Yeah, I have it.
Okay. Then when we go to do, that'll take us through number 7. Number 7, you'll end up with a graph like this. When you go to do 8, they change the game where they want the times to get squared. So 0 squared,
Or 9, 18,
those remain the same. Do a new graph, it should do this for you. It should just be a straight line.
Wait, you said the numbers on both sides stay the same?
So this is 7, this is 8. These will stay the same for both 7 and 8, these are unchanged. These got squared when they created number 8's table. They wanted to square the times.
Why is that stuff
They told you to just square the time. They didn't say it very clearly, but the way they phrased that question, they're telling you, leave distance alone, square the times. Let's look back and see how they phrased it. But 7, they asked for, 7, they asked us to plot distance time. So distance time is the way we had that set up. When they go to do 8, they say to graph distance versus time squared. So you're not doing anything to change the distance. It's a repeat of the same distance. But they want the time, only the time to be squared.
I thought it was asking us to like do the equation again and change.
No, just keep the distances you had already gotten. Just make the times squared. Anybody else, anything to do with anything from 66? The most important stuff in terms of you doing the review sheet and one day taking the test, there is a question like 5 on the review sheet and the test. So you want to make sure you got that. The way that we had to do some areas and some slopes, both on number 3 and 4, there are questions like that where you have to find the areas and the slopes on some different things, so that mattered. The things where you're drawing tangent lines, that's not going to make the test. I'm not going to like do a test where we get out graph paper and everybody like guesses what the slope will be, and I have to decide if he says 12 and she says 13 and she says 14 and 15 and 16 and 17 and 18. At some point people are wrong. Where is that point? I'm not going to try to officiate that. I mean, at some point someone's got to be wrong, but everybody's guessing. I'm not up for that. Last call. Let me give these back to you then. Draw you a decreasing slope. Decreasing slope, yes. Decreasing slope, no. Why decreasing slope, no? Why is that bad news? Because it changed direction. This is a picture for changed direction. This is getting less steep, yes, for a while, but once you hit here, then what did it start to do other than change direction? Get steeper again. So it's like slowing down, slowing down, slowing down, slowing down, stopping, getting faster again, just coming the other direction. So people that took these pictures and started to bring them back at me, that's not what we're after. We only want to do the back at me if we change direction. There's a bunch of people on change direction which have this, but I still took half a point off because you missed a little bit of a tidbit of the direction. You had to mark where it changed directions. Where did it change directions?
At the top.
At the top. So I'm looking for some kind of a marking where it changed the directions on that picture. So I did half this time. That would on the test get you done. Curl back, I think I was doing half points for curl backs, maybe, or maybe not. I'm not sure. But on the test, if you do a curl back on me, that won't be worth anything. The decreasing slopes are going to level off to have zero slope. Namely, what's zero slope about? Right. Other stuff on quiz? Anybody? Answers that you want to know about? Yep.
How would you draw number 4 on the back?
Number 4 on the back, the rest is just a file.
Or it's still not.
Somebody else, anything fronts or backs, because all of this makes the sheet tomorrow, all of that makes the test, it's all coming back, every spec of it. Anybody, anything?
10, 12.
10 and 12, you're needing to do areas, so you could literally draw me any shape, I could care less what shape you draw me, but show me that we're gonna get an area of something. I don't care what the shape is that contains the area. Draw me a triangle, a rectangle, anything you want to do an area.
Well, 11 is just that, right?
11's another, 11's the same as 4 is the same as 6, I think? No. Yeah. I don't have my key in front of me. There's 3 that are this picture though, and that's one of them, but 11 is doing that. Anybody else, anything back or front? Okay, one thing about the review sheet that people sometimes overlook, and then you don't really practice something that you're better off to practice, is when you get to the way back, no, not the way back, the middle back, when we're 80 to 89, is that the way back? Okay, so when we get to 80 to 89, each of those questions is looking for 2 things. It's looking for an acceleration, which if you want to fill in, that is found by doing the slope. And we're also after the distance, which is the area. So you're doing both a slope and an area for each of those. That's like a 10-point zone, not a 5-point zone. It's kind of like the way the chapter review did it. They drew you one graph. They wanted the slopes for one, the areas for the other. Once I drew the graph, I just felt like doing everything, because why should I and why should you bother with 2 crazy graphs if we could just do one crazy graph and do 2 things with it? So when you do that thing in the 80s, make sure you're doing a slope and you're doing an area to do 2 different answers. Last call, last call. I had last call a bunch of times. This is really the last. Okay, we're done.